Okay, so now we will discuss chapter 7 in the P2 book, differentiation. Okay, so write the topic differentiation. So then under differentiation, the first subtopic that we are discussing about increasing and decreasing functions. Okay, what are increasing and decreasing functions? So they say here we can use the derivatives to determine whether a function is increasing or decreasing on a given interval. So increasing means what? Basically, if your graph is rising up. So if you have a graph and if the graph is moving up, when the x values increase, the y values are moving up, you can see the y values increase. That's called the increasing function. A decreasing function means what? When x values are increasing, the y values are decreasing. It shows some kind of a decreasing pattern. Okay, so it's a decreasing function. Okay, increasing function is the graph moves up. In a decreasing function, the graph moves down. Okay, so however, now what we want to do is they give you a interval of x values, like they say between x values 0 to 5. Is the function increasing or is it decreasing? Like you have to decide. You have to speak about it. Okay, so then what we do is, children, what we do is to decide whether your function is increasing or decreasing. What we do is we have a look at the gradient. We have a look at the what? The gradient. In the previous P1 book differentiation, you will learn the gradient is actually what? The gradient of a curve is given by dy by dx. Dy by dx is the gradient of the curve, or even we even say it's the gradient of the tangent to the curve. Do you remember? So this dy by dx is the gradient, and we say if you have a positive gradient means the graph is increasing. That means the y values are moving up. If the gradient is negative, if your dy by dx is negative, it means at that point the graph is moving down. Okay, that's decreasing. So basically, a positive gradient would mean a positive gradient means the straight line is like this, which means your graph is moving up. Okay, so if you have a negative gradient, now when you draw the graph and at any point on the graph, if the gradient is negative, that means the graph is moving down. So just to show you, like for example, in this quadratic graph, you can see if I draw a tangent at this side, you can see these tangents have positive gradients. Straight lines with positive gradients. And then if I draw tangents to the other side, you can see this other side has negative gradients. Do you see? So this side is the increasing part and the other side the y values are decreasing. So this side if you draw any tangent, they are having a positive gradient. So this side if you draw any tangents, these tangents have negative gradients. Is that okay? So we'll write down this particular rule. The function fx is increasing on the interval a to b, a comma b. This is the interval of x values. Okay. The function fx is increasing on the interval a comma b if f dash x means what? F dash x is another way of saying dy by dx. Okay. F dash x is another way of saying dy by dx. If f dash x is greater than or equals 0 for all values of x such that x is greater than a less than. Basically what they're trying to tell you here is, let's say we have this interval of x values. So I have this interval of x values starting at a and ending at b. And let's say I have my graph going from a to b. My graph moves from a to b. And then during this interval they are saying, between the interval of x values a and b, can you see the interval is a to b. Okay, so inside this interval a to b, the function fx is increasing if what? If the gradient f dash x is greater than or equal 0 for all values of x, which means if the gradient, now if you draw the tangent, you get the gradient, right? If the gradient is positive for every single value of x in between this a and b. Okay, it's not a big thing. Basically, a very simple thing. All you need to do is, whenever they say a positive gradient, whenever they say the function is increasing, you must use that f dash x is greater than or equal to 0. Whenever they say the function fx is decreasing, you must use the rule f dash x is less than or equal 0. Okay, let's first note down these two rules. Note down these two rules and then we'll see how to apply these rules in the sums. Okay, so let's have a look at the two graphs that they have given you here. Now, when you look at this, the first graph, the y equal x cube plus x graph is drawn in the first example. Can you see? So in this example, do you notice that as x values increase, now you start from the negative side of x and you go to the positive side. So you can see when the x values increase, the graph goes in this direction, right? This is how the graph moves. So when you go along this direction, what do you notice about the y values? Do you have a fx increasing function, or do you have a place where the fx is decreasing? What do you see here? The function is it increasing or decreasing? It is increasing. Clearly it is increasing, right? So you can see for every single x value, like for all x values, this particular function is increasing. Okay. So, but look at this function, the second example. I think we can see that there are many turning points here, right? So, what do you notice about the first section of the graph? If I come from here to here, if I come from here to here, you can see this blue color part of the graph. What happens? We are moving down, right? We are moving down means function is decreasing. And then if I draw this the green color part here, you can see during this part the function is increasing. It is increasing because you're moving up. It's increasing. Y value is increased, and then again you can see after the turning point it's moving down. Do you see? So again this part you are decreasing, and then again after this point you are again increasing. Do you see? So let's say the function fx is increasing on the interval between -1 and 0. Now remember this interval is a what interval? This interval is given with x values. So they are saying in between the x values -1 to 0. Okay, in between, because you can see here the x value is -1, right? And here the x value is 0, right? In between x value is -1 to 0, your function is increasing. Do you see? And they say, and it's decreasing on the interval between 0 to +1. Do you see in between x value 0 and +1, your function is decreasing? Can everyone see that? And then again, when it's greater than 1, it's again increasing. Here, when it's less than -1, it's again, it's decreasing, right? Less than one side, the function is decreasing. Between -1 and 0, function is increasing. Between 0 and 1, function is decreasing. Again, after 1, the function is increasing. Okay, so that's how it works. So basically, there is one more thing you need to do. You can see here they use we use here. Did you see that we use the function fx is increasing on the interval if f dash x, your dy by dx is greater than or equal 0. Do you see the equal 0? Now, normally dy by dx or f dash x equal 0 happens at what places? Equal 0, if your dy by dx is equal to 0. You will learn this in your O levels also. If your dy by dx is equal to 0, what does it mean? Yeah, that is correct. Yeah, it's a stationary point. I have an answer on the chat. It's a stationary point. Or it's a turning point. Okay, so then can you see here they use f dash x is greater than or equal 0 and less than or equal 0. Now they say here if f dash x or your gradient is greater than 0 for all values in the interval, the function is said to be strictly increasing. What do you mean by strictly increasing? Like it's only increasing. Like it is strictly increasing. But when you have greater than or equal 0, we say it's increasing. However, at equal 0, we come to the turning point. Okay, we come to the point where the gradient levels, where it becomes parallel to x-axis. So they say if you need to show that a function is increasing or decreasing in your exam, you can use either strict or non-strict inequality. So they are okay with both. That means if you want to say your function is increasing, you can, basically they recommend you to use this f dash x is greater than or equal 0. So even if you say the function is increasing, so shouldn't I use f dash x is greater than 0? That's also fine. This is a strict inequality. We call this one a strict inequality. Do you see why? Because in this strict inequality, we only want the ones where it's definitely increasing. Not even getting equal to 0, because getting equal to 0 means you're at a turning point. Okay, so this is not something big. It's just that you need to know. I want you to know about it. Okay. And then the other one, the interval. Can you see this? The interval a comma b. They have given the square bracket. Is a set of all real numbers x that satisfies x is greater than or equal a, less than or equal b. So I wanted to make a note of this one. So a comma b. The meaning of a comma b is x greater than or equal a, less than or equal b. Basically, this inequality is what they have given inside this bracket. Okay, so that's what I want to know. Do you see that they have given here -1 comma 0? This -1 comma 0 here, it means x is greater than or equal -1, less than or equal 0. Okay, so this is another way. This square bracket is another way of giving a range of x values. Okay, so the square bracket means you must put the equal sign. Is that okay? So make a note of that part and then we'll move on to the exercise. Okay, so now we'll move on to the next part. Exercise 7a. Find the values of x for which fx is an increasing function given that fx equals to part A. Let's do this one. They want you to find the values of x where fx is an increasing function. Okay, so first one, yeah, fx is given by 3x square plus 8x plus 2. Okay, so how do you find the values of x where fx is an increasing function? What do? You must first get differentiate. You must first differentiate. So get f dash x. F dash x is the first derivative. When you differentiate, what do you get? 3x square. When you differentiate, you know you take the power in front and you subtract 1 from the power, right? So what do you get here? You get 6x to the power 1. 8x differentiation is simply 8. Can you all remember P1 differentiation? 8x differentiation is simply 8 and plus 2 becomes 0. Plus 2 becomes 0. This is f dash x. So if you want for fx to be an increasing function, for the increasing function, what is the rule? An increasing function means the derivative f dash x must be greater than or equal to 0. It must be greater than or equal to 0. So basically your f dash x is 6x plus 8 is greater than or equal to 0. So you get 6x is greater than or equal minus 8. And what do you get here? X is greater than or equal minus 8 divided by 6 is minus 4 over 3. So x is greater than or equal to minus 4 over 3. Can you understand? Okay, so we'll try a few more. So I did the part A, y'all can try part C. Y'all can try part D. Try part E. Okay, do these few sums. Try these sums first. Okay, we'll do part C. Part C, fx is equal to 5 minus 8x minus 2x square. So first thing is we'll get our f dash x to get the derivative, the first differentiation, the dy by dx. Differentiation of 5 is 0. Minus 8x differentiation is minus 8. Minus 2x square differentiation is 4x. Is that okay? And then what do? We need the values of x where fx is an increasing function. So fx is an increasing function means f dash x is greater than 0. F dash x is greater than 0. So minus 8 minus 4x is greater than 0. Greater than or equal. Yes, greater than or equal 0. Minus 4x goes to the other side as plus 4x. And then I will remove the x to the 4 to the other side as division. So it's an equality sign. Remember, it's sensitive to the division of a negative number. So here, because I took the minus 4x as a positive 4 to this side, I mean this 4 is a positive 4. I'm dividing by a positive 4. So therefore, the inequality mark is not flipped. So minus 8 divided by 4 is minus 2. So basically, the answer is x is less than or equal. The mouth is close towards it. So x is less than or equal to minus 2. Okay. Okay. Okay, then we'll move to the next one. Part E. Fx is equal to 3 plus 3x minus 3x square plus x cube. So let's get f dash x. So f dash x, when you differentiate 3, you get 0. Differentiation of 3x is plus 3. Differentiation of 3x is simply 3x. Differentiation is 1. Minus 3x square, 3 times 2, 6, x to the power 1. 3 minus 6x to the power 1 plus x cube is 3x square. I'll do part D afterwards. Okay, so if my f dash x is correct, right? Yeah, 3 minus 6x plus 3x square. So now what do we need? We need the function to be increasing, which means we want our f dash x to be greater than or equal to 0 for the increasing function. So 3 minus 6x plus 3x square is greater than or equal to 0. So what do you see here? Do you see it's a quadratic, this is called what? a quadratic inequality. It's called a quadratic inequality. So this is something you learn in P1, how to solve quadratic inequality. So what do? I'll arrange this nicely. 3x square minus 6x plus 3. Basically, I just rearrange 3. I just brought 3x square in front and the plus 3. Like the same equation is rearranged. Y'all can see here that actually 3 is a common factor, right? 3 is common to everyone. We could divide the whole inequality by 3. So we are dividing by a positive 3. So will the inequality mark flip? Or is there anything happening to this? No. If we are dividing by a negative number, only the inequality mark will flip. Okay. So we can divide the whole inequality by 3 and it will not change the side of the inequality sign. Okay. Everyone is divided by 3. 3x square divided by 3 is x square. 6x divided by 3 is 2x. 3 divided by 3 is 1. Greater than or equal 0 divided by 3 is 3. So this is what we get, x square minus 2x plus 1. Okay, so then let's factorize this. Is it possible to factorize, or do we need to go for the equation? It's x minus 1, right? It's x minus 1, x minus 1. Okay, basically it's x minus 1 square is greater than or equal 0. Is that okay? Okay, so I think y'all can see here the 3 I divided. So y'all can see that x minus 1 square. Now when you look at the square function, y'all know that regardless of whatever value you put for x here, when you have a square number is always what? It's always positive, right? So x can be anything. X could be a negative figure, x could be a decimal, x could be positive, x could be anything. But it doesn't matter whatever it is when you minus 1, whether the final answer is a positive answer or negative answer. When you square it, we are definitely sure it's a positive answer. Are you all with me? So do you see that this produces always positive answers? So do you see that this inequality, is it satisfied or not? Can every x value satisfy this particular inequality? Yes, because if you put x is 1, you'll end up getting 0. However, this inequality has equal 0 also, right? So equal 0 is also there. When x equal 1, because the only value who doesn't give you a positive answer is when x is 1. When x is 1, you get 1 minus 1, 0 square, which is 0. So this has the equal to 0 option as well, right? Equal 0 is also there. And then every other x value gives you a positive answer, which is greater than 0. So you can see every single x value here is satisfying this inequality. So what is the answer? Your answer is, in this case, what are the x values that makes your gradient positive or your y values are increasing? So it's all the x values. So when it's all the x values, we write x is the element of the real numbers. That means you can take every single x value on the x-axis. For all x values on the x-axis, the graph is increasing. The graph is just going up. This is a cubic graph, so probably it will go like this. I'm just showing the shape. It's going to be increasing forever. It's not going to make a turn or do anything like that. Okay, so basically it's a graph like that. For every single x value, your y values, your function is increasing. Okay, that came because we got a square of the whole function. Then let's go to the part. I need to do part D, right? I left out part D. Part D I should discuss. Part D, fx is 2x cubed minus 3x square minus 12x. Okay, so what do we have here? F dash x. When you differentiate, 2x cubed differentiation is 6x square minus 3x square differentiation is 6x minus 12 into x differentiation is 1. Is that okay? Is that okay? 6x square, 3 times 2, 6x to the power 1 minus 12. So then for the increasing function, what's the requirement? Your f dash x must be greater than or equal to 0. So f dash x is 6x square minus 6x minus 12 is greater than or equal to 0. Is that okay? So I'm doing the second question part D, right? Okay, so apologies. Let's do the first one part D again. First question part D. Fx is 2x cubed minus 15x square plus 36x. Okay, let's get the f dash x and get the increasing function. Now it's correct, right? 2x cube minus 15x square plus 36x. Okay, so let's get the place where the set of x values where the function is called increasing. So f dash x gives me 6x square. 15 times 2 is 30x plus 36x differentiation is 36. Is that okay? So your function is increasing when your f dash x is greater than or equal to 0. So f dash x is 6x square minus 30x plus 36 is greater than or equal 0. Do you agree with me? This whole inequality we can divide by a, this whole inequality I can divide by a 6. Can divide by a 6 and that will not affect the sign of the inequality sign because I'm dividing by a positive figure. So I end up getting a 6x square divided by 6 is x square. 30 divided by 6 is 5x. 6 divided by 6, 36 divided by 6 is 6. This will be factorizing nicely, right? X minus 3, x minus 2. So basically we have a quadratic inequality. And this is something that you will learn in P1, how to solve quadratic inequality, something like this. Now you can see this is different from the previous part, right? In the previous part, I did not go for any quadratic inequality, any theories in P1. The reason being I got the same bracket twice, like I got a square function. In a square function, every single, I mean, it is always positive or greater than or equal 0 and for every single x value. So I didn't need to go for any special theories here. But for this one, you can go for your P1 theories. So what do you do here? You could draw the graph. One way is to draw the graph. Another way is to draw the number line. But basically, all you have to do is check the places, check the ranges of x values. Who makes this function what? Greater than or equal 0 means what? We need this value to be positive. So I want the set of x values who gives the answer for this guy, who gives this answer to be positive. You could use the graph, you could draw the quadratic graph, or you could draw the number line and do any method is fine. Okay, so number line and graph are basically both the same thing. So what are the two x values we have here? X minus 3 means what? The x value is plus 3. And x minus 2 means the x value is x minus 2 means the x value is plus 2. Okay, then what you could do is, if you want, you could do the number line method is a lot easier, I feel. What you could do is you could input a x value in the, now you can see there are 3 regions here. The region that is less than 2. So I will say this is my first region, and the region between 2 and 3 is the second region, and the region after 3 is the third region. Okay, or else, I mean, basically all you need to do is to determine whether in each region, whether it's positive or negative. Okay, are you all with me? So after you come to this point, what you could do is you could draw the graph or you could use the number line method, anything is fine, okay? Basically, you need to select out of these 3 ranges, in which range do you get the positive answers? Because you can see here, we need this answer to be greater than or equal 0. I need to select the positive range. So to do that, one method is you could draw the x square minus 5x plus 6 graph. Basically, we have the 2 roots, right? X equal 3, x equal 2 are your 2 roots. So if you draw the graph, I mean, it's a quadratic, which graph? Minimum or maximum? It's a plus x square means you get a quadratic minimum graph. So if you draw the graph, you would end up getting a graph that goes through 2 and 3 and makes a minimum. This is what you would get. Okay, if you use the number, I mean, basically what, if you use the number line method, what you would get is, the number line method is, I mean, any method is okay. If you use the number line method, what you would get is, you could type the whole thing in the cal. You can type, the graph is minimum because it's a positive x. Then here this is x minus 3 plus 2. Minus 3, the other one is x minus 2. Okay, so then what you do is, now you know there are 3 ranges here. In range number 1, you have x values that are lower than 2. Give x value lower than 2, what do you get? Give x value lower than 2. We could give x is 1, 0, minus 1, minus 2, just give something. So when I give x value 1, do you see what kind of a y answer am I getting? I'm getting 2 here. It's a positive answer, right? Shall I try minus 1? Can you see I'm getting positive answers? Even if I give minus 10, do you see that I'm getting positive answers? So basically for all the values of x behind 2, I'm getting positive answers. Do you see? This range gives me positive answers. So now in the next part, what you do is give a value between 2 and 3. So let's go for the next range, 2.5, a value between 2 and 3. Okay, a value between 2 and 3. So this, the decimal here is actually, the comma is the decimal here. So what do we get? You can see we get negative. Can you see we get negative? So for any value, minus, sorry, not minus, between 2 and 3, 2.1. Can you see I get negative? For any x value, 2.9, I'm getting negative. So everything between 2 and 3 is negative. After 3, yeah, at 3 it will be 0. That's the whole one. At 2 and 3, the graph should be 0, obviously here. So if I give x is 2 or 3, I will get 0. That has to be the case, right? Because those are the two cutting points. The graph also tells you that. Then when at, let's say, greater than 3, what can you give? You can give 4, you can give 5, you can give anything. So you can see it's all positive. Can you see? So at this part of the graph, it's positive. Now, which part do I need? So can you see this graph also verifies that? Do you see in the first range, the graph is above the x-axis. Therefore, y values are positive. Do you see in the second range between 2 and 3, the graph is behind, below the x-axis. Therefore, y values are negative. It verifies this, right? What I have over here. And when the graph is after 3, you can see it's going again above the x-axis, which means y values are again positive. So that this number line method and the graph method are basically both the same thing. They're both the same thing. Okay. You can use either. Okay. So anyway, I want the region where what? This is positive. Where do I have the positive regions? Do I have one answer or two answers? Okay. So we have two answers. We have two answers. Therefore, the first range is what? Where x is less than or equal to. Do you see? Because I have the equal mark is there here, I must go with the equal sign. X is less than or equal to the behind range. Do you agree? And the other one is the range where x is greater than or equal to 3. So x is less than or equal to, or x is greater than or equal to 3. So these are the two number ranges. You cannot combine this and write in one inequality. You cannot combine this and write in one inequality. The reason being that these two regions are separated. Do not attempt to write this together. Never write it together. You can only write it in equal two numbers together if they are following one range. Okay, so when the x is less than 2 is definitely going in a different direction. X greater than 3 goes in another direction. They are not together at all. So these two ranges must be separately written. Okay, do not combine them. Question number 2. Look at question number 2. Find the values of x for which fx is a decreasing function. Given that fx equals to, okay, so fx is given. How do we find a decreasing function? In a decreasing function, what is the requirement? The f dash x or your gradient must be, the f dash x or your gradient of x must be less than or equal to 0. Less than or equal to 0. So let's get f dash x. So your f dash x is x square is 2x minus 9x, differentiation is 9. So for decreasing function, what's the requirement? F dash x must be less than or equal 0. So this is 2x minus 9 is less than or equal 0. Minus 9 goes to the side as plus 9. Less than or equal 9 divided by 2, right? So x is less than or equal 9 divided by 2. Do you understand? 4.5. Then let's do part D.
It is converted to x minus 9 as x bracket x minus 9. Then that is
Part D, fx is equal to 2x cube minus 3x square minus 12x. So let's differentiate. And differentiating, we get f dash x is equal to 2x cube is 6x square. 3x square differentiation is 6x minus 12. Right? 6x square minus 6x minus 12. So what do we get here? f dash x for a decreasing function, f dash x must be less than or equal 0. Right, so f dash x is 6x square minus 6x minus 12 is less than or equal 0. So you can take the 6 out, right? Or you could divide the whole inequality by 6. It doesn't affect the sign of the inequality. So 6x square divided by 6 is x square minus x. 12 divided by 6 is 2. It's less than or equal to 0. Is that okay? So then we have here, let's factorize. What are the two factors? X
minus 2 x minus 2 plus 1.
x minus 2 x plus 1. X minus 2 x plus 1. So I think the number line method is the easiest. I mean, any of the two methods are fine. You must use one of them. The two x values are x equals 2 and x equal minus 1. So basically, I think this is a plus x square. So this is the main thing you need to focus on. Okay, so when this one, you can say, okay, this is less than or equal 0 now, isn't it? Which means I want this to be negative. So you could use the number line, you could use the graph, I don't mind, any method is fine. So it's a quadratic minimum graph again, because I've drawn the plus x square minus x minus 2. So basically behind 1, you guys can see the y values are positive. Between 1 and 2, the y values are negative. After 2, the y values are positive. You could use the number line method, or you can use values in your cal and type and do in the way I did earlier. Anything is fine. From the graph, we can directly observe. That's why. So what do we need here? Less than or equal 0 means I want the negative values. So what are the negative values? I have only one range where I have negative, right? From where to where? From 1 to 2. So in this case, it's one range. It's not separately there in two regions. So this is the correct region, which means your x values are what? Greater than or equal minus 1, less than or equal to 2. X is greater than or equal minus 1, less than or equal 2.